Thank you for the introduction, Andre. So as you can see, yes, we'll be going through introduction to Victron GX products and Node-RED integration. And the solution we'll be covering this evening is grid Setpoint with ESCOM as a backup. So I'm just going to start this over there. So on the agenda this evening, we'll be looking at what is Node-RED, the GX controllers that are compatible and recommended by us, how we are going to use it, so the solution that we're going to look at, configuration, the practical, and at the end we'll do questions and answers and any sort of discussions. So what is Node-RED? Node-RED is a flow-based development tool for visual programming, as you can see in the picture there. It is built on Node.js, and flows are written in JavaScript. So users can write function nodes using JavaScript to process data when it does become a bit more intricate. But for this evening, we'll only be using the nodes that you can see in the picture over there. So I just want to quickly go to the next slide. Recommended and compatible devices will be your Servo GX and Servo SGX, your Venus GX, and your Ekrano GX. That is something those are the products or controllers we recommend. We do, however, know that the Multiplus 2 GX, the 3 kVA and the 5 kVA can also do so, but these controllers have a much bigger processing capability, therefore ensuring your nodes and your flows to run a lot better and at 100% without any issues. So we like to stick to these controllers when it comes to using Node-RED applications. And then let's look at the next one. So the solution being covered this evening, it's going to be broken down into 3 separate categories here. The first one will be eliminating grid Setpoint, so temporarily taking your system off grid. Number 2 will be ensuring the grid is connected for scheduled weekly charge. That is something that is quite important in the field. That is something to really consider. If your battery is not being topped up at 100% at least once a week, something you definitely look at adding a schedule in the ESS settings on your servo. But we'll be looking at ensuring that is done once a week and it is met. And then the third thing, ensuring the end user cannot the minimum SoC below what the VE config file settings are. That is also quite important because if the end user can, they will switch off their inverter by mistake and it won't come on until the minimum SoC startup is met. So that is also something that is quite important that we need to look at and ensure the end user cannot make these sort of adjustments if they do not know what they're doing. So we'll look at that as well. And then I just want to go to one more slide. The compatible installations. This is something we do need to chat about before you look at this sort of solution on your Victron installation. The first thing you want to do is make sure your system must have enough battery storage to power you through the night. This is quite important, as if it can't, then it does not make any sense to look at this sort of off-grid solution. And secondly, your system must have enough PV installed to fully recharge your battery bank throughout the next day. So whatever was used in the evening needs to be able to be topped up the next morning by at least noon or early afternoon, I would say. That is a good estimate. So basically, on average, your system should be able to work off-grid for at least a few days, especially when there is sunshine. I mean, obviously, we've had some bad weather now in Cape Town, so you can't really scale us on the weather we've had now, but on an average winter's day, yeah. So I'm going to quickly go into the VRM environment here and click on Andre's installation. It's the one we use. As you can see, we're going to go to remote console, and you can see in the background there is a bit of a grid Setpoint, 42 watts, and it jumps up and down. Next, we'll go into menu and settings, and then firmware. We'll scroll down to online updates, and we'll find image type. Default, it is on normal, but you need to change it to large. That is quite important. Then we're going to go to check for updates. As you can see, there's update available. I'm not going to do it right now because I do need the servo and it does take a minute or two to happen. But once the update is complete, you go back onto your servo, remote console, and you can check if it's installed correctly by scrolling all the way down. You will find something called Venus OS Large Features. Something's been added there at the bottom. You'll click on that function or that feature, and you'll scroll down to the node red. We'll ignore Signal K for now. That is something they use in the marine industry. And we'll click on node red, and we'll ensure that it's enabled, not enabled safe mode, but enabled standard. Enabled safe mode is a different function. It limits your flows and your functionality from node red, and we won't look at it this evening. Another way you can look at, make sure everything's installed correctly, is you can exit out of the servo or the remote console, and on the side of the panel there, you can see there's a Venus OS Large setting over there. If it's not there, just refresh the page and make sure it comes up. Then we're going to click on the node red square. While it's loading, I just want to show you another site where this solution is installed. As you can see, there's no grid set point. And on the side here are the ESS controls with battery SOC minimum SOC settings. I just wanted to show you that that's the environment. You should be familiar with it by now. Andre does not have those features because he has a RS inverter, and the ESS functions are not available on that just yet. So this is how the Node-RED environment looks once it's loaded. These are the different templates. As you can see, we have a few templates that we have stored here that we are working on and developing. We've got some Eskom push integration going on, some WhatsApp integration. But yeah, there's basically some things we work on. And you can scroll through the different flows. You can see they are not enabled. Here's the flow that we'll be working on. I just want to delete this one because this is exactly what we'll be doing. But I want to start fresh. I'm going to add flow. I'm going to double click on it and give it a name so we know what we are doing. I'm going to call it grid set point. And I'm going to press done. And now we have a clean page. So as you can see here on the left, this is all the nodes that are available for us to use. We've got function, switch, and change. Those three nodes we'll be using extensively this evening, so just remember those. We've got an Eskom push API, and as you can scroll down, there's a bunch of available things we can use here. As you can see, Victron Energy have loaded their nodes or APIs here on the side for us already. You don't have to import anything. It is done already when you work through the servo itself. At the end there, you can also see there's a WhatsApp API. So these are the inputs and outputs you'll be using. The inputs will bring us data from the Victron installation, and the outputs will control the installation. So in the beginning, we want to look at importing data from the installation. So we're going to look at battery monitor. As you can see, if you hover over the node, it gives you a nice breakdown on what it does. We want to look at battery monitor first because we want to read in the SOC of our battery storage. So we're going to drag it there. We're going to double click. As you can see, 100 has a BYD premium LV battery, and we're going to choose the measurement, which is going to be state of charge, SOC. I'm not going to label this node at the moment. I don't like to label the Victron nodes because I feel like they, by default, label themselves pretty well, as you can see. And I don't want to cause any confusion just yet. Then we're going to scroll and we're going to look for the change function. As you can see, if you hover over, it gives you a good thing. So it's a function that sets, changes, moves, or deletes in data. We want to use the set function. So we're going to drag it there and double click. As I said, we're going to use the set function. So we're going to make sure it's on set. We're going to change this to flow. We're going to set it to a flow. And we're going to change to the value to message. We're then going to use payload. So I'm going to drag it down instead of typing it out. I just use payload because that is the conventional method of a message. So we're going to leave it at that. Then we're going to give the flow a name. We're going to call it SOC, something easy to remember, as we'll be using it later on in our flow. Then we're going to name the node, something that is also quite easy and something that we all remember what it is. So I'm going to call it SOC percentage. You can label whatever or name it whatever you want. If you want more information on the node, you can click on the little book there and it will give you everything that the node does, nice and broken down and easy to understand. Then we're going to press OK, and we're going to connect the two together. As you can see there, just as easy as that. Now, to check that this works, we're going to use a node called debug. We're going to place it over there, and we're going to connect the SOC to debug. As you can see, it's debug 8. We're going to deploy, confirm deploy, and on the right here, you should be able to see if you press on the bug. These other messages are from the other flows from earlier, but if you can read there, it says node debug 8, and it says 50. So that is the percentage of 100's battery at the moment. It's 50%, but it'll come in as 50. And it's polling every second, which is correct. And that flow is working so far. So we're just going to disable it for now and delete that information to clear it. Then we need to look at bringing some more information from the Victron installation. So I'm going to scroll down to the Victron nodes, and I'm going to pull in a node called ESS. So as you can see, it gives a nice description. And yeah, I'm going to pull it to underneath the BYD battery. I'm going to double click on it. And this time we're going to press on the ESS function, and we're going to use Venus system in this instance. And we're going to scroll into measurement, and we need to bring in the active SOC of the system so that we can make a high level and a low level, which I will discuss soon. I just want to bring in all the Victron information first before I continue with the change functions. I'm going to bring in another ESS node underneath, and I'm going to double click, and I'm going to use Venus settings on this node, and I'm going to look for ESS state. So that is something we want to use and we want to monitor. So as you can see, this is not mode, this is state, and you'll see we'll be focusing on number 9, keep batteries charged, and number 10, optimized mode without battery life. Those are the two that we'll be focusing on this evening. So we'll press done, drag it up there. Then there is one more node that one more piece of information I'll be needing, and that is that scheduler that I was talking about earlier to ensure your battery is charged weekly. So there is no node for this at the moment, but what there is a custom node at the bottom, a custom input, which we can find there. And it gives a nice explanation. I'll drag it in there and double click. And what this does is it brings out any other custom information that you might need, like in this instance, the schedule function. So we'll choose Victron Energy System 0, and we'll scroll down until we find the schedule function. Maybe not the easiest thing to find. There it is. Schedule charge. And we'll press done. Now we need to look at storing the information from these 3 nodes. So we'll be looking to use the change function again to set the data. So I'm going to just scroll up here quickly. And there it is. Okay. So I'm going to bring 2 change functions in for the active SOC limit, because we need to create a bit of a change. So either we'll set a lower level, which will be what the active SOC is at that instance, and we'll bring in a higher level, which will be plus 10%. So I just want to quickly neaten a few things up, but I'll walk you through how that will work now. I just want to bring in the different nodes and set them up so it looks neat and nothing is confused. But basically, yeah, as I said, we'll be bringing in that active SOC that is set at that instant, and that will be the lower level. And we need another setting, which will be the higher level, which we will use a function node to add 10% to the active SOC. And we will be using that information later on in the flow, which we will talk about now. So then I'm going to bring in a function node. This is what I was talking about earlier. It's programmed using or coded using JavaScript. So the first one, I'm going to set this one, I'm going to call it lower level. There we go. Then I'm going to keep it to set. I'm going to change this to message and bring down the payload, use flow, set to flow. And I'm going to give it something easy. I'm going to give it LL for lower level. And that is it. Done. Then I'm going to go to the, I'm going to drag it over, connect those two nodes. Then I'm going to go to the higher level, and I'm going to give it its name called higher level. And I'm then going to set that to flow again, and message, bring down the payload, paste it over there. And I'm going to set this flow to HL for higher level. Okay, easy as that. And then I'm going to go to the function block. I'm going to give that a name. I'm going to call it increase lower level by 10%. That's exactly what it's doing. That's as easy as it is. So the small code, not that easy, not that hard either. Quite simple. You're gonna say, you're gonna type over there, click over there, and you're gonna type message.payload. So it's the information that the Venus or that the active SOC is being pushed in by the active SOC node. This is the message payload. We'll be saying equal is equal. Sorry, plus, sorry, no, equal. Equal message payload plus 10. So it'll take that message payload and it'll add 10 to it, which will give you the 10% higher than what the active SOC is at that instance, or at any instance. And we'll press done. Then we're just going to connect the nodes together. So not a lot of JavaScripting there. That was quite easy. I'm sure if you are not sure, you can always ask us, or ChatGPT can help you with some simple JavaScripting as well. Then I'm going to connect the ESS state to this change node over here. I'm going to just quickly set this one. I'm going to call it I'm going to call it ESS, ESS state. So I'm just taking time, ESS state, and then do the rest of the settings. I'm going to just call it 9 or 10 because those are the two settings that it will be at. So I'm going to call that flow, message, same thing as the rest of the change nodes. And I'm going to give this flow name ESS state. There we go. And done. I'll then connect the two nodes together. And then lastly, the schedule charge node. I'm going to give this a name, and I'm going to call it store schedule. And then I'm going to do the same as the rest of the nodes flow. I'm going to call it message, and I'm going to call the flow SCH, just something easy to remember. We'll be using it now again. And I'll connect those two. Okay, so that is all the information we'll need from the installation at the moment. What we can do now is we can debug and test if we are reading everything correctly. Just a reminder that, as I said, Andre's installation doesn't have an active SOC settings. So when we deploy this, we'll see, okay, this is the other messages from the other flows, but we'll see, if you look down here, debug 10 gives out number 10. So that means it's adding. And debug 9 is null or null. That is because, obviously, as I said, Andre doesn't have that function on his installation just yet. So, but it is reading, which is a good thing, and it means it's working. I'm then going to just stop it, and I'm going to clear everything so we can continue. But yeah, so that panel on your right is where you'll see that the information is working. I'm just going to delete everything. It's nice and clear when you test things. Next, which has also got a nice feature, is I'm going to group this information side or this data storage. So you just select everything, right-click, node, group selection, and give it a name. Double-click on the outline and just give it a name. I'm going to call it stored data. And as you can see, you can then drag it wherever you might need it to create some space, which is quite nice and quite handy. Right, now we need to go into the functionality of the flow of this whole solution. I'm going to zoom out a little bit just so you can see everything at the top there as we go. So first thing we need to do is go to the nodes that we'll be using now, which will be the switch and the change. So what we'll be doing in this side is we'll be bringing the data we've stored in the change function to the top there, and we'll be using it now in the next section here. So we're going to bring on the switch node. This node compares data to what it receives and gives the appropriate output that you ask it to. I'm going to call this one scheduled check or schedule check. So it'll check the schedule and if there is any at the time or in the moment. And we'll use SCH. That's what we use there. I'm then going to use the not equal to function, not equal to 1. And I'm going to use the otherwise function. So if not equal to 1, then the schedule is obviously off, and the inverter can look at being off grid. Otherwise, if it is any other input, like 1 or 2 or whatever, but most probably 1, then obviously the schedule is active and the system needs to be on grid to charge the batteries fully. So that is quite important to understand. Then we're going to bring an on-grid node here. This will be a change node, which we will call on-grid, and we'll give that 3. We'll make that a number, set the value to 3, which we'll discuss later. It's just the position of the inverter. And as you can see on the scheduled check node, there's 2 little dots now. So we're going to connect the otherwise dot to on-grid. As easy as that. And then I'm going to pull in another node. I'm going to put another switch node in. And this one will read the ESS state. So if it is keep batteries charged or not, what's 10? So it means keep batteries charged. I'm going to pull it ESS state. Obviously, the system cannot be off grid if it is keep batteries charged, because it needs grid to also then charge the batteries. This flow is going to be labeled ESS state, which is what we stored earlier. And I'm going to make this not equal to 9 and add another function, and I'm going to make it equal to 9. So if it is not equal to 9, then obviously it's not keep batteries charged and the system is running as it should and it can be off grid. If it is not 9, if it is 9, if it is equal to 9, then the system needs to be on grid if it is equal to 9, which is keep battery charged. So I'm going to pull the bottom node, which is equal to 9, down to on grid. Then I need to bring in another switch node to compare some more data. And that will be the higher level and lower level that we set there, or the active SOC. So we're going to call it SOC check. We're going to give the property flow, and we're going to make it SOC. So it's going to bring in that charge of the battery. SOC check. And then I'm going to quickly change this to just quickly forward here. Okay, sorry. Yeah, it's not SOC check, it is just SOC. I was just wondering why that was wrong. So that's going to align with that. And then I'm going to double click on it again because I need to set the higher level and the lower level that we've made over there. So double click. I'm going to bring in a function. So as you can see, flow is SOC, so it will read the data, and I'm going to make it that if it is greater than or equal to higher level, so HL, then obviously the system can go off grid because there's more than enough battery. And I'm going to make the second function if it is less than lower level, which is the active SOC at any instant. If it is less than the active SOC, it needs to be then on grid. So I've again made two different outcomes. Then going to connect it to the top of the SS check. And the third thing I'll do is I'll drag now, again, if it's lower than the active SOC, take it on grid, make sure the system is on grid so it can charge its batteries. Obviously, it's not capable of going off grid then. Then I'm going to bring in another change node, and I'm going to call this one, this will be the off-grid node. So it will be the node that sets your system off-grid. I'm going to call it, yes, obviously I'm going to call it off-grid, and then change it to a number, and that's going to be 2, which is the switch position for off-grid, and I'm going to take the high level to off-grid. So there's 3 different checks your system will do before it just takes your installation off-grid, which is quite important. Those checks are quite important. Gives it nice functionality and ensures that the system's not either going on and off the whole time, or it's ensuring that your batteries are well charged up for off-grid capabilities. Then I'm going to bring in a output Victron node, which will control the inverter. So we're going to look for Andre's inverter, which is a multi-RS. So we're going to choose the multi-RS control. As you can see, if you hover it over, you can ensure that it's the right one. And when you double click on it, it will come up with the inverter you have and the serial number, which is quite fantastic. And you know you have the right thing. Then we're going to choose switch position. As you can see earlier, 3 is on grid, which is the number we chose, and 2 is inverter only, which is off grid, which is also the correct number we chose on and off grid. Now we can connect these 2 nodes to the inverter control, but then it will poll the inverter every second with the same number or the same information the whole time, and it's really not good for the processing power of the inverter, and it's just too much. So what we want to do is we want to use a filter, which is this node over here, and if you scroll over it, you can see it gives you a short description, and we want to put it in between the 2 outcomes going to the inverter. And if you double click on it, you want to choose the option. As you can see, there's quite a few here. We want to say block the top one, which is block unless value changes. So if the inverter is in position 2 the entire time, You don't want it to poll to the entire time the inverter and tell it to be on grid, off grid the whole time. It must only poll to the inverter again if a state changes. Let's say it now needs to go to position 3 because battery has depleted. Then it will obviously be a different value. It will now be 3, and it will then, the filter will recognize that and send that information to the inverter node, causing the inverter then to go on grid. So that's quite nice. That can help you make your flow a lot more efficient and user-friendly. So I just want to quickly neaten it up a little bit so we can see it all in one go. And I'm going to also group this little flow here. So I'm going to go to group selection, and I'm going to label it as well by double clicking on the outline. I'm going to say grid set point. So that's the, I would say, most complicated part of the whole webinar, this little piece here, because obviously it's the control of the installation or of the flow. So we've done the data storage and we've done the grid set point solution or control. The third thing I wanted to touch, which we did discuss in the PowerPoint, was obviously ensuring that the end user cannot set their minimum discharge value to lower than what the VE config file setting is. So to do that, we're going to bring in an ESS node, and we're going to leave. We're going to select the Venus settings, and we're going to scroll down, and we're going to select minimum discharge SOC, because that is obviously what we want to read in. We're just going to bring it over, and then we're going to select. So I'm just zooming in and out just so I can make sure you guys can see everything. We're going to then use a change node again, and we're going to double click and give it a label. We're going to call it min discharge SOC. There we go. And then we're going to do the same as the rest of the data we stored. Change that to message, sorry. Change that to flow. Bring the payload down to message. And we're going to give this one an easy one. We're going to just say dis SOC. So we set the flow to, and then we're going to connect it. So now we can read the minimum discharge SOC into the Node-RED environment, which we could have also done in the beginning in the other stored data, but I just wanted to bring this all as one little solution here at the end. Now we're going to bring in a switch node. We're going to double click. We're going to call it check min SOC check. And we're going to change that flow to what we labeled the min discharge SOCs. So it was dis SOC. And if it is less than 21, so if the user tries to decrease their minimum discharge to less than 21%, the system will pick it up. And we then want it to change from that 21, something a bit higher. So we'll call this one, we'll use this change node to do so. We'll call it change to, sorry, that was meant to be changed to 22. So we want to change it then to 22%. We want to bring it a percentage up to give the system some play or some time. So we're then going to change that to 22, and that will then output that when the client now tries to swing down, there's a little obviously there's a little bar that you can then swing, and when they try and set that to below 21%, the system won't allow it, and it will take it back immediately to 22%. So let's say your ESS, your Victron config file settings is 20%. We've then given the system 22% to play with. We're then going to bring the minimum discharge SOC with another ESS node. This is the ESS control. So the output, we're going to connect it there. Not going to do much. And then we'll just say, just want to neaten it up like that. And then we want to group this as well, so we know what it's about. This also helps us when you do come unstuck, or there's a problem you're facing, something's not working correctly. It's nice when you have grouped and labeled your different sections, so that when someone else like us or another technician comes on site or logs in, they can see what you're trying to do, and you've got your labels there. It makes it a little bit easier for us to diagnose everything and do some fault finding. Right, so there we go. You've got your 3 sections. And now we want to test if it works, especially the grid set point control function. So as you can see, everything set up nicely over there. So what we're going to do is we're going to use a debug function again, and we're going to drag it to the output of the filter. And then we're going to use an inject timestamp, and we're going to put that into the beginning of the schedule check. Just make sure it's going to work correctly. So this will just mimic the installation as being live, timestamp, and the debug will show us the message that will work. We'll just change this so we know what when we view it on the side there of the panel, we can then see what we're looking at. So we're going to call it inverter position. And as you can see now, on all the nodes is a little blue dot. Once you deploy and everything's successful, the blue dots will disappear. As you can see, then everything is green on the Victron side, so that means it's connected, and the blue dots have disappeared. So everything was successful. Those 2 messages are from the other flows, as I mentioned earlier. So now I'm going to press timestamp, and it's going to say successfully injected timestamp, but there's no message. So let's just check. No, there's no message. So that means there's a bit of a fault somewhere. So we're going to quickly do some fault finding. We're going to go to our first node. Everything looks good there. Second node. Oh, okay. I didn't change this to flow. So obviously it's not then communicating with the stored functions or the stored data. So if we press it again now, deploy, let me just delete that. Then it should come up. There we go. So inverter position is 2, which is then off grid. And if we open up a VRM portal again, and we go on to 100 installation, it should then be what that switch position is, which is number 2 off grid. So just give it a second, go to Andre's house. And as you can see, it is off grid and there is no grid set point. So that means it was deployed successfully and the environment is working correctly. We cannot check the other minimum discharge thing because Andre's, as I said, no, he doesn't have that function just yet. But yeah, that is the basics of it all. I really hope this helped. And if you do have any questions, Andre will help us with that now. And yeah, thank you so much.